Hi, this is a quick CS341 sample video in order to look at template matching and image distances when you've got a little bit of an image that you're trying to match to a bigger image. I've got my test image, which is a picture of a dog. Here we have him, her, not sure. And then I've got some templates. This one, which is called tiny.jpg, actually matches. This is just a cutout of the image. This one, which is called not so tiny.jpg, doesn't match that dial, but maybe matches somewhere else. And I've got some code which will match the template to the object. So starting off with, we're going to look at template matching with the right size template and various types of distance measure. So this is the correlation coefficient, and on this one we can see there's a peak here. White is good for the correlation coefficient, high values, strong correlations is what we're looking for. It's got a match here corresponding to some circular features on the dog's collar. You can see there's also a very good match in the right place, but the strongest match is surprisingly not where we're looking for. If we look at normalized correlation coefficient, we see that the peak over here, where it's supposed to be, is exactly where we found it, and it's matched the template in exactly the right place. Other distance measures you might want to use include square differences or sum of square differences. With this one, a high value is good, so we want the sum of a low value is good. So with the sum of square differences, if the differences are low, so zero, hopefully, what we do is we look there for the matches, and we can see that the sum of square differences has found exactly the right place. And finally, normalized sum of square differences, again it's found the right place, and you can see more clearly in the visualization of the distance between the template and the image at each point. The distance is at lowest in the right position. So that's that's the baseline, right? That's trying to match the right template to the right image. What happens if the template is not the right template? So let's try, in my code I'm just going to comment out the line where I read in the tiny template, and I'm going to uncomment the line where I read in not so tiny, write it out again, and then run the code again. So what we're doing now is we're matching the wrong template, and hopefully what we'll see is it's rubbish. Oh look, it's rubbish. There you see the template has actually matched a big piece on the dog's forehead. For that correlation coefficient. For normalized correlation coefficient, it's matched a piece of the controls, but not the right piece of the controls. If we look at the template, this one, no, this one. I'm not entirely sure why that's matched there, but I suspect it's to do with the mixture of light and dark that we've got under that particular point. If we look at sum of square differences, it's actually matched one of the dials, just not the right dial, and that's kind of more what I was expecting to happen here. And finally, if we look at the normalized sum of square differences, again you can see it's matched the wrong part, but similarly wrong to the normalized correlation coefficient. But you can also see there are some dark patches here where it's matching in approximately the right place, just not quite as well as it is matching over here. So that's matching the wrong template. Another question I've had about this is what happens if you blur the template? What happens if you blur the image? And in my code I'm blurring the image here, and what I want to do now is, instead of matching the original template, we're going to match the blurred template. So I'm just commenting out the matching line, so I'm changing which particular template we're matching, and this is matching the small template, so it should match, and we're blurring it, so it should perhaps be more robust to small changes. What we're seeing though is that for the correlation coefficient we've got the same problem that we had with the unblurred one. With the normalized correlation coefficient, again we've got the strongest match in the right place. With square differences it's found the right place, and with normalized square differences again it's found the right place. So that didn't really show you that blurring gives you more robustness to change, but it does at least show you that blurring the template will still work in many cases. Okay, hopefully that clears some things up.